So if you have chapter 5, is it Renal? Could you turn off the front lights for us, please? Just the front. There we go. Thank you. Okay, let's stop talking for now. Okay, you can talk after. You have a long weekend ahead of you. Okay, so we have geometry here. I'm just gonna grab my key here. Then I remember what to review before we jump in. So if you go to this section right here, we're gonna start with classifying triangles just in general, all kinds of different triangles. So obviously we'll start with 3 sides triangles. Remember, I always give you an overview before I jump in. And then we're going to go into 4-sided shapes. So you have your parallelogram, right? Your kites, your rectangles, squares, you name it. But we're going to talk about 4-sided shapes. So they're called quadrilaterals or quads, right? So we're going to do 3-sided first, then 4-sided, and then we're going to end up with polygons. So try to draw a pentagon if you can. Right, you've got your pentagon, you've got your octagon, which is basically a stop sign, right, and so forth. So 5 sides, 8 sides, and that just continues. So many sides, and we call those polygons. And really, polygons encompasses every shape you can think of. So quadrilaterals and triangles are also part of the polygon family. But we tend to just separate these two. And then when we get to 5 and more sides, we call them polygons. That's normally how we refer to them. Okay, so that's what we're going to be doing. So today we're sticking with triangles. Then we're going to move over to quadrilaterals. And then last, we're going to spend time on polygons in this unit. So, so probably 2 days, 2 days, and then 4 days on polygons. Okay, more or less. And before we jump in, so remember, there's a reason why I did trigonometry before I did geometry, because now you know sine law and cosine law, and you can actually solve for angles and sides in a triangle. And that works with any type of triangle, right? So keep that in mind. So when we have a right triangle, okay, I need you to do this for me, please. Don't worry about the letters so much. I want you to always recognize if it's a 90 degree, across the 90 is always the longest side, and we call it the hypotenuse. Okay? And we call the other 2 sides legs. Okay, so leg and leg. It doesn't matter which one is which. We just know hypotenuse is here, therefore the other 2 sides are going to be referred to as legs. So when we review the Pythagorean theorem, we have 2 scenarios, 2 cases. Okay? The first case is you have a missing hypotenuse. If the hypotenuse is unknown, you use this formula. Hypotenuse squared is equal to leg squared plus leg squared. And so that then it follows that to get the hypotenuse, you would have to take the square root of the sum of the squares, basically. So that is a very important, I'm going to always jump straight to this. Okay, this is going to be the one I will jump to if I want to find the hypotenuse. The other case is missing leg. So if you're missing either one of them, you would say that the leg squared is equal to the hypotenuse squared minus the other leg squared. So emphasis on the minus, right? There's a subtraction there. And so it follows that to find the leg, to get rid of the square, you just take the square root of hypotenuse squared minus leg squared. This is going to be very handy to quickly find the third side because we're going to do a lot of right triangles. We're going to work with a lot of right triangles here. And remember this. I hope this makes sense. Only works with right triangles. Okay. Only works with right triangles. And you need 2 of 3 sides. Okay. Those are the conditions for Pythagorean theorem to work. Okay. Okay. All right, so next page. So when we go to 175, I want you to right off the bat scratch remember SOHCAHTOA vaguely from grade 11? Yeah, so I want you to not worry about that. I don't want you to mix up sine law, cosine law with those. I used to teach it again, and then on the final exam, students would use SOHCAHTOA on triangles. Go ahead, where it just doesn't make sense. Okay? So don't use SOHCAHTOA here. We're going to use sine law, cosine law all the time. Most of the time, sine law works. Okay? So calculate the length of the missing side. So, of course, this is your missing side here. And that is our hypotenuse. So label it across the 90 is always your hypotenuse. So that means that the other two are our legs. Okay? If you can identify the hypotenuse, then you know the other two are legs. And watch this. If you're missing your hypotenuse, right, if you square that, you would have to square the legs and add them up. So let's go ahead and do that. So no particular order. Okay, you square them. Sorry, and I will bring my hypotenuse squared down here as well. And so the hypotenuse is simply the square root of whatever I get here. So it's similar to how I dealt with cosine law, right? That's 146.12, sorry. So if you square root that, you get 12.09. And we are in centimeters, so that's it. And you know why I use hypotenuse? I don't use ABC. I know your teachers in grade 11 or 10, they might have used C squared as A squared on B squared, right? And why is that dangerous? Is this C? Would your teachers have told you that this is C? They would have said C is your hypotenuse, right? But you're solving for A, so that gets confusing. So if you just know whatever this letter is, I know it's my hypotenuse. So that means that I have to add the legs, the up, right? Square them and add them. And of course, there's always a square root involved, always. I will probably do this in 2 lines moving forward. I won't use 4. I'll just set it up like this and solve and get the answer, okay? Try this one here. I will purposely draw it in such a way that you're not used to it. Draw a triangle like this and put the 90 up here. This is 17.8 inches. This is 12.7, no, 12.6 inches. And determine this, determine that side. We can call that x, right? Find side x. So I will do this one with you because there's a couple coming up just now where you will practice and put this to the test before we move on. This is not what today is all about. Pythagorean theorem should be something you already know, but I just want to review it because I'm going to use it from time to time. So in this case, across the 90, this is my hypotenuse, right? So leg. So that means that if this is what I'm trying to find, it's one of my legs, so I know that leg will be the square root of hypotenuse squared minus the other leg squared. I have to subtract in this case. And so x, right, which happens to be the letter associated with my leg, is 17.8 squared minus 12.6 squared. Okay, so x is square root of that's 158.08, and you cannot have negatives in there, so make sure you understand that. That's 12.57 inches. It should be shorter than the hypotenuse, right? Like whatever you do, hypotenuse is always the longest out of the 3 in a right triangle. Okay, let's put this to the test, see if you remember how to do it. So flip over to the next page here. And C obviously is a little bit trickier, but try A, B, and then give C a try. So let's go, up to 10 minutes. Okay, just follow along. Hypotenuse missing, right? So y is really square root of 69.3 squared plus 47.6 squared. Y is the square root of that. So y is 84.07 centimeters. Okay. And then over here, the hypotenuse is there. So leg and leg, so we're missing one of our legs, right? So that is really hypotenuse squared minus the other leg squared. So that is this, which is 70, 60. Let's pay attention, guys. 77, 60 millimeters, okay? And then our last example, yeah, here we have to find this first, so you can give this a letter. So on this particular, for this triangle, you always start with the one with the most info given, okay? This is the hypotenuse, so leg and leg. So guys, I need to I think I need to split you guys up because it's getting too much for me, okay? 89.5 squared minus 68.4 squared, because we're missing one of those. Okay, so that is 333, 1.69, and that is 57.72. And technically, because we're not finding the final answer yet, 7208, right? Because as you work, in most cases it won't affect us that much, but it could. So now if we're looking at the second triangle, P is our hypotenuse, right? So that's what we're missing. So to find P, we have to take the square root of 57.7208 squared plus 46.9 squared, right? Because now these are our two legs and we're missing the hypotenuse. So that gives us 5,531.3. Take the square root of that. P is 74.37, which you probably got regardless whether or not you found used 4 decimals here. But if it does end up being a different answer by probably by 0.01, then you would lose a rounding mark there, half a mark. So if you want full marks, basically I say this, use double while you're working, and then your final answer round to 2. Okay, use 4 along the way, final answers to 2. Okay, we're gonna skip a bunch of pages because I know you know how to solve. So we're gonna go to 179. It says working with properties of triangles, and I want you to add classifying triangles at the top of this. Classifying triangles, because this is what today is all about, being able to name them. Okay, so if you have a highlighter, I will do that as well. So when you go through it, it's right there. And so this is also stuff that should be on your study sheet. What I'm about to talk here, I will highlight the important parts. So basically remember that everything is still true about triangles. The sum of interior angles is always 180. And then we'll talk about some of the notation that will follow as well. And so this is the first part that I need you to know. So if you're supposed to classify by angle measure, there are 3 options. A triangle can be acute, right, or obtuse. So you only have 3 options, but only one of them will apply. I will tell you this, if there is a right angle, if you see that box here, that always trumps everything else. Like, so if you're between acute and right, it's going to be the right triangle, the right angle that's going to win, even though all of them are less than 90, right? So acute, all 3 angles, right, measure less than 90. Okay? Right, 1 angle measures 90. Obtuse, 1 angle measures more than 90. Right, greater than 90. And so just keep that in mind. So this would be obviously this is your obtuse. So as soon as you have one of them, it's obtuse. Okay. If you have a box, it's a right. If you're not sure if all of them are less than 90, of course it's going to be an acute triangle. Okay. Fair enough. Next page. By side length, you could have an equilateral, an isosceles, or a scalene. Okay, scalene triangles. It has all sides are different, all angles, no angles are equal, right? And isosceles, two sides are equal, two angles are equal. It's basically what you need to remember. An equilateral, obviously all three sides are equal, all three angles are equal as well. Three sides are equal. Sorry, sides, right? Three sides are equal, three angles that are equal. And by the way, always acute. An equilateral triangle is always going to be acute. Why? Because when we have an equilateral, we know it doesn't matter what the side length is, it's always 60. All three angles are 60. That's what I wrote in there. So it's always acute, this one. Okay. And now, so you will always have to try to find as much information about the triangle as you can just by looking at it first of all. And then you might have to do some calculations on top of that. So every triangle will have a first name and a last name. So a triangle could be a right. So you pick one of these for the first name and one of these for the last name. So how about we do that? First name. This is on page 179. This is the first name. And the other chart is the last name. So everything will be a right scalene, a right isosceles. Is there a right equilateral triangle? Can't be, because what are the angles always for an equilateral? 60. You don't have a 90, right? So sometimes I'll trick you that way. I'll say, hey, draw me a right equilateral triangle. You should just say it's not possible, right? Don't try to draw one because you can't. Okay. Here you have a diagram. Use a different color for this. I would suggest I'm going to fill in what I know right off the bat without calculating a thing. Okay? So these markings tell us that this side and this side is the same. So we can transfer the 20 centimeters onto the other side. And this is another thing we know. If these two sides are the same, we know that the angles across from those sides are also the same. So can you go back up? I forgot to mention that up here. Go back up to this chart. If this side has an angle, it will be exactly the same as the angle across the other side that it measures the same. Okay, so these two angles are the same. And to really illustrate that, let's draw another one right beside it, because students get this wrong because they think it's always the bottom ones. But let's say you have a triangle like this, and these two sides are the same. That means that the angles across, right? So opposite to those two sides are going to be the same like that. So you go across arrow like that. Okay. Okay. Okay, what else? So inferring what we just learned, okay? If this is 53 across here, and we know that these two sides are the same, I also know that this angle right here is going to be 53 degrees also. Okay, does that make sense? You always have to be careful with when they split it. There's a lot of stuff going on. You can easily just cover that up for now and just look at the whole thing. Okay. Do you know angle A at this point? If you have 2, so let's find that angle A is going to be what? 180 minus 2 times 53. Does that make sense? Instead of minus 53 minus 53, I can just go minus 2 times the angle that I know already, right? And so that is 74. So I'm just getting a whole bunch of information that doesn't take long to figure out. Okay. So now I can answer what they're asking me for. What's the length of side BC? So they want this whole thing here. Okay, this down here is side BC. So there's 2 options here. You can use Pythagorean theorem, or you can use sine law, cosine law to do that. So watch here. I'm going to use, we can use sine law, right? Because we know that this is a pair here. Sine of 53 over 20 centimeters is equal to sine of, which one am I going to use if I want to find BC? 74. And so I'm just going to use that the same notation because it shouldn't throw us off really. BC is equal to 20 times sine of 74 divided by sine of 53. And so we go and find that out. It's 24.07. And we are in centimeters. Could I have used Pythagorean theorem for this? Okay, I want to make sure though you understand why. Because yes, the answer is you can. This is a symmetric triangle, meaning if you cut that in half, you get 2 exact same halves, right? But don't always think that's going to be the case because I'm going to add something here, so I encourage you to do that. This, if these 2 sides are the same, it's symmetric. You can cut in half, no problem. But this is asymmetric. If you have something like that, asymmetric, can't cut in half. Very important because I have students like, oh yeah, I'm just going to cut it here and then I have 2 exact same halves. It's like, no, not really. Can't do that. Right? If you cut this here, right? Obviously, it's very obvious. If you cut this here, right? Make sure you cut it in half, then you're fine. So this one, yes, you could cut it in half because we know that these 2 sides are the same. And so if you use this right triangle and find x using Pythagorean theorem, you can multiply that by 2 to get the whole length across. So yes, and I think you get exactly 24 if you do that. So that's okay if you're off by a little bit. Okay, classify triangle ABC by angle measure, so we're going to do that, and by side length. Okay, so how would we do that? Well, we have 2 sides that measure the same. Only 2, right? Because the third side is longer. So that makes this, what kind of angle, when we go by angles, go back to that page on 179. You have 3 options, acute, right, and obtuse. This would be an acute, right? So acute, that's the first name, and then the second name, side length, isosceles, that's right. Okay, so you have acute isosceles, first name, and last name, okay? That's how you name, this is what we call classifying, right? So classifies name that specific triangle, okay? So acute isosceles, how did we do that? We came up with a whole bunch of information just by applying, right? What do the notations, what do those little markings mean? All of that stuff. And that's how we were able to do it. Okay, moving on. It's not too bad if you follow along and you practice. If you don't, if you think like, oh yeah, I got this, but then later you're going to be faced with examples that you will not have seen before, then you might be in trouble. So flip over to that blank page. I will give you a whole bunch to practice because this book doesn't give you a whole lot of examples. So you're going to have to copy these. Okay, so classify. The following triangles. So I encourage you to use a different color to fill in some of that information you need to be able to give it a first and a last name. I will go over it, so don't be afraid to risk right now. So every single one of them should have a first and a last name, just as we did it on the previous question. So give that a try. Let's go over this. Make sure we put our phones away, okay? So for this one here, there's a lot of things that tell you already what this is going to be, right? So this is a right, and it's all three sides are different, so it's scalene. That's what this is. Okay. On this particular instance, this is our 90 here, And I know that these two angles are going to be the same, right? This angle is going to be the same as this one. But that doesn't really, it's not very important for us to know, as long as we know that this is going to be a right. And because two sides are the same, this is isosceles. Okay, so there's that. C is, we know that there's one greater than 90, so that is an obtuse scalene. Okay, and this one, we know that if this is 60, let me use a different color. If that's 60, then we know that this is 60 as well. And then you should recognize, wait a minute, if these two are 60, then this third one is also 60. So this is actually an equilateral. If you wrote down acute equilateral, that's fine. But it's equilateral, that's all you need to say there. And on this one, we have our same scenario. This is 25, therefore this is 25. And so you need to make sure you get that third angle. So if this is 25 and 25, that's 50. That means that this has to be 130. So this is actually an obtuse isosceles. Okay? Obtuse isosceles is what that is. Does that make sense? Am I making sense, or is that are you struggling a little bit? Well, practice will make this a little smoother. Okay, so if this is 45, then I know from this side going to the other side, this is 45 there, and you should recognize, hey, this is 45 and 45, that's 90. That means that this has to be 90, right? I figured that out after the fact, right? I went across, got the 45s. Easy to find the third angle. So this is a right isosceles, right? Because these two are the same. Does it make sense that it's isosceles, right? Even if the markings had not been here, the two angles being the same tells you that, okay? So it's either the two markings or the angle measures themselves. Okay, keep going. Okay. As you can tell, right, we finish a unit, we continue right away. So this is going to be a pattern. So get used to it, okay? Use the following diagram to answer the questions below. Before I do anything, I will look at this diagram and fill in the information I know right off the bat. So if this is 60, then that means that this must be 60 also, right? Which means that this, I will show you the math, right? I will just go 2 times 60, right? 180 minus 2 times 60 is also 60. So what's the measure of M? Well, we already know that. That's 60 degrees. It's known to us. Classify triangle MNP by angle measure and by side length. By the way, if you flip the last name and the first name, I will not take marks off. As long as you have the two, that's all I need. So by angle measure, this is definitely an equilateral, right? Equilateral, no doubt about it. Acute equilateral if you want, but you don't need to. Continuing. Question 5. What is the length of side PR? So they want this whole thing here. Okay, we will call that X. So think about it this way. If the markings here tell me that this is 8, then this is 8 as well. So this is my what? My hypotenuse. because I have a 90 here, I can use Pythagorean theorem to find that out. Okay, so x is going to be found by taking 8 squared plus 8 squared and square rooting that. 8 squared and 8 squared is 124, no, 28, sorry, which is in turn 1131 meters. That's all I needed to do there. Okay. So Pythagorean theorem, classify PQR by angle measure and side length. PQR is, right, PQR, it's this triangle here that we're talking about. And we know that it is a right isosceles, right? Right isosceles. Classify triangle QRS by side length. So QRS, right? They're talking about this one here. And we know that this is a 90. This is S, R, and Q, right? So I cut it. Is this a symmetrical triangle? It is, because two sides are the same, and if you cut it, you're cutting it in half perfectly. So we know that this is a 90. How do we know that? If you go back, this is a straight line, right? So they add up to 180. So if that's 90, this has to be 90 as well. Do I know this angle here? What was cut in half? So that would be 45, right? Because you have 90 divided by 2 gets you that one there. Does that make sense? Because it's symmetric, if you cut it, you get 45. So if you have 90 and 45, then we know that this one is 45 and 45, right? It has to be two 45s make 90 and another 90 make 180, okay? So without doing any further calculations, we know that this is a right isosceles as well. In fact, have you heard of fractals ever? Okay, if you keep cutting in half, you will get the same triangle over and over. Like for example, if you cut this like this, and then cut that one like that, right? And then you cut that one like that, and then you cut it. Like if you keep cutting it in half, you will always keep on having right isosceles triangles, just forever, right? So that's just fractals for you. Tessellations, remember that? In grade 9, 8, 9, your teachers made you cut out. You just made the same thing, repeat it, the pattern just repeated. Yeah, you did. You might have forgotten, it's been a while. Okay, 183 now. Wait, what happened there? Oh yeah, sorry. I'm okay. 183. I want you to try and answer question 183 and 184. This is all one question. This roof that you see down here is all part of this question here. Okay, so work on page 183 and 184. Two questions, really. They're just multi-step questions. And see if you can do that, if you can figure it out. It won't be that long, but this whatever we did today will cover that then. Okay. Okay. So pay attention. An asymmetrical roof, as seen below, has sections 18, 14, and a rise of 6. How wide is the building? Okay, so there's various strategies that you could have used to find this. You could have just cut them both. You cut them both into right triangles and find x and y and just add up those two to get your answer, right? So to get x, I just go 18 squared minus 6 squared. Anybody use sine law or something? You get 288. Square root of that is 16.9706. Y on this side is going to be 14 squared minus 6 squared. That's 160. That's 12.6491. So to answer A, I'm going to go way up here. To answer A, I'm just going to go x plus y, which is 16.9706 plus 12.6491. And that is 2962. And we are in feet. Okay, so this answers question A. So that one, I mean, multiple steps, but it should have been easier to answer. B, classifying. Okay, so I'm going to do that underneath here. Yes. Yes. Will do, yeah. Thank you. All right, no problem. Okay, so ABC, triangle ABC, A, B, and C, that is obviously a right. And what would we call it in terms of side lengths? Every single side is different, right? So it's a scalene, right? Sorry, this is regarding triangle ABC, okay? And then this other one, ACD, right, is also a right scalene because all three sides are different. So triangle ACD is also a right scalene. And now the answer to this one here, how would you do that one? We know it's a scalene, right? That part we have figured out, or at least you should have, because all three sides are different. But we need to figure out the angle. Is there a potential for an obtuse angle at the top? There is one. There's a potential there. So a couple of things here. I'm going to use a red pen maybe. So on this side it's 25. So forget about this for a bit. Forget about the 6. But do I have a pair? I do have a pair. So I'm going to, is this going to give me a problem? Hold on. This is going to be a problem here because sine law doesn't find obtuse angles. So this is what I'm going to do. And I will never throw this at you, so you don't have to worry about it too much, but I have a pair. I will use this 14 to figure out this angle here, and then I will figure out A. Okay. So I'm going to go sine of 25 over 18 is equal to sine of B over 14. Sine of B is 14 times sine of 25 divided by 18. And that is 0.328, right? So it's sine inverse of 0.328. That's 1919. That's this angle right here, watch. I'm going to go arrow, just point it to that angle right there. So that means that angle A will be 180 minus 25 minus 1919. That's 135.81. So therefore, it's an obtuse scalene triangle ABD.